Okay. Hello, good evening, everyone. Can you hear me? Just confirm if you can hear me. Yeah, okay. All right. Okay, so welcome to the seventh session of the course. And so before we begin, do you have any questions from the last week's? Like, we're done with half of the course. So anything you want to ask? Any queries? Yeah, anything? Okay. So, so if there is nothing, then fine. So this just blank screen was in case there's anything we want to discuss. So I have an R script prepared and we'll go through it. So there were 5 lectures in this week's in this week. So we'll just go through it one by one and giving like always quick summary. We'll practice some questions alongside, some at the end, and then we'll also take a look at last week's assignment. And if time permits, there were a few questions from the first and the second assignment that some of you had a doubt on. If we still have time, we'll just quickly go through that. Okay. All right. So the week began with discussing this function here. Okay. So now you remember from the previous week, from week 6, we have talked about functions, right? So you can define functions on your own, and there are so many inbuilt functions that you've been using all these weeks in R, right? So one such function is the function seq, short for sequence. So whenever you want to find the sequence of, whenever you want to make a vector, some sort of a sequence, so there are different ways in which you can do it. So here you can see 3 of the ways that mostly you use, okay, whenever you're working with R. So this one, the simple one, you've seen before, right? So this function is called combine, and basically you can give it anything in any order, any number of elements. Yeah, the functionality here is that you can give it in any order. However, the thing is that you need to mostly you'll need to individually mention each of the elements, so it can become a little cumbersome if you have a lot of elements, right? So here I just had, like, for example, eight elements, right? Okay, so quick check. How do I, if I don't have this thing on the right side, how do I find the how many elements are there in a vector? What uh, command am I going to use? Okay, this was taught initially, you've been using it, so remember, just type in, yeah, length. Okay, I will just recommend you that whenever you're writing the name of function, it's just simpler, it's good for yourself, that you'll just enclose it in parentheses, okay, curved brackets. The answer is correct. Yeah, so I'll just write length of x and I'm going to get the number of elements in it. Okay, so that's one way. And this another way which we have, um this is quite simple, especially if you have to make vectors where each of the elements are, so first of all, they have to be in an order, increasing or decreasing order, increasing, decreasing, increment, decrement, ascending, descending, whatever you want to call it. And they are differing by unit 1. So they are either increasing one by one or decreasing one by one, right? So for example, the simple one here, 5:9. So this is going to give us the first element is 5, adding 1, 6, adding 1, 7, 8, 9. It's going to end at 9. Now, if instead of 9.5, sorry, instead of 9, I give 9.5, it's still going to give me the same answer. Why? Because if it goes to the next element, which is going to be 10, it is actually going to increase this upper limit. So it won't cross that. Okay. And then likewise, I can also do a decrement. So the first element is 9, and then it's going to go down 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2. Right? Now it would not exceed -2 because now even in the number line, if you think, so -3 is lesser than -2. So it won't go beyond, it won't jump that limit. So if you are asked questions like this, that what is going to be the output, and you're confused, just draw the starting and the ending points like you would draw on a number line, and just, see that if you're going one by one, either increasing one or decreasing one, you should not cross the second number here, whatever the second number is. Okay. And similarly, you can start off with a decimal value, right? So if I start from 9.6 and say, 9.6 colon 20, so it's going to go 9.6, 10.6, and so on until, can you tell me what the last number here is going to be in this one? 9.6 colon 20, what is the last element in my vector here? 19.6, right? Yeah. Okay, so you can see this thing here. And can you tell me the output again? So 5.7 to -3. So we know it's going to decrease. So can you tell me the last element in for this one? So it's going to be 5.7, then 4.7. So can you tell me what would be the last element here? Yeah, good. Okay, so now 5.7, 4.7, 3.7, 2.7, 1.7, 0.7, and then 0.7 minus 1. That's minus 0.3, right? So, and then -1, minus 1.3, and then again -1, minus 2.3. So, right, so when you're going from plus to minus, just if it's not half, plus minus half, then you're going to have a change of the decimal number. So don't be confused in that. Okay. All right. So first way, use the combine function. Second way is to use the semicolon, the colon here. Now the third way is to do using this seek function here. And if you take a look at what all arguments the seek function offers, so we have seen how you can put a question mark followed by the name of the function, and then you can check what it is doing, right? So it's a sequence generation, like the topic, the main name of the function is sequence generation. It's going to give you a description and the usage. So yeah, now sequence. So it has all these arguments from, to, and by. By is actually that increment or decrement. You can specify, you don't longer have to have increment and decrement of just one unit. It can be decimal numbers, 5, 6, -8, 8.3, anything. Okay. And then there are a few other arguments also that it offers. So one is length out, and the other is along with. So we'll see these two also today. So the simple one, from, to, by, this you can see, right? Okay. So again, from 3, so you start from 3 and you go all the way till 7. It's not necessary that you will have 7 as the last element, right? Because here you're saying that by the change has to be of 0.3. So now if you run this, you can see it's 3, 3.3, 3.6, all the way to 6.9, but it won't cross 7. So that's the same thing here. But now here you need to be a little bit more careful that this by has to have the correct sign. So if I say, okay, from 3 to 7, and if I'm changing the sign here, I'm saying -0.3, so it's going to give me an error. It's saying that you have the wrong sign in the by argument, because from 3 to 7, you cannot have a negative change, right? So this is going to give you an error, right? And in one of the other lectures, you had also seen that here you can give any of two of these arguments also. So let's say you can skip, you can skip from. So you're saying 2 is equal to 7. And then you're saying by is equal to 0.3, for example, and length dot out is equal to, let's say, 5. So now what it means is that I want to go to 7 and I want to go in steps of 0.3 and I want a total of 5 elements only. So that means my last element, because that's 2, so my last element is 7, and then I am going till 7 in steps of 0.3. So I can go back from 7 in the opposite direction in steps of minus 0.3 and take 5 such elements. So the first element therefore becomes 5.8, 6.1, 6.4, and so on. Okay. So likewise, you can also have seek, where you're saying you can tell the starting point, and then you can also say by whatever, let's say 0.9, and then you can just say length dot out is equal to, let's say, 4. Okay. So again, it would mean that you start from 4, you go in steps of 0.9 and give me 4 such numbers. So that's it, 4 elements. Okay. So these things are there, right? So this length dot out is, so we have seen this, these first four arguments here, from, to, by, length dot out. Okay. And now the last option here, which is along with. So now the exact usage of it might not be apparent right now, but let's take just an example. So here, let's say we have this other data vector, right? This one that we just defined here. So now if I say sequence of this data vector, or sequence along the data vector, or sequence along with this data vector, all the three things, any of the three things. So now what it gives me is that it gives me the indices of this one. So you remember how in the for loop, right, we used to say for I in some numbers, or we say I from like 1 to 10, right? Because you're iterating over something, so you want a particular sort of a sequence. It's a very simple sequence, relatively simpler sequence, right? 1, 2, 3, 4, 5, 6, 7, 8. So something like that. So when you're saying, so you're defining the sequence of a data vector, which is nothing but its positions. A vector is defined by its positions, right? So any of these three things that you see here, they're all going to give us the same answer. Okay. So sequence along a vector gives its indices. So it's just something you can keep in mind, and we'll see if in one of the upcoming classes we can put this to use. But yeah, you can consider this to be sort of used along with loops and all that. Okay. So you've seen this. So that finishes the first lecture of this week. Okay, lecture 26. Any questions until here? Yeah. All okay? Okay, fine. Great. So the next part comes something to do with date and time. So mostly we're working with a lot of date formats here. Okay, so now there are a lot of uses of why you would need to save, or rather keep a note of the date or the time. So I can give you two examples. So can anybody tell me, so do you know about random numbers, random number generator? uh anybody would you like to tell something about where do you think random numbers could be used? What are random numbers to begin with? Any idea? No? Okay, fine. So now let's say some you want to pick, let's say you have 1 million numbers with you, okay, or 1 million. Let's say you have so many, you have a, let's example, you have a big box of balls. Okay, you want to, there are 1 million of them and you want to pick some of them, right? So we say in probability that you are randomly picking 10 of them, okay, 20 of them. So now if something like that, if you want to do something like that in R or in any programming language, you want to simulate some sort of a probability distribution. So a lot of times you would like to say that, okay, so you are doing it one time. So out of 1 million of those samples, you would like to pick 10 of them. So you randomly, basically what you're doing is you're saying, okay, I have numbers written from 1 to 1 million, which is 10 lakh. So 1 to 10 lakh, and I want to pick any 20 numbers from that. So I am generating 20 numbers. Okay, I'm asking the system to give me 20 numbers between 1 and 1 lakh. I'll do that once. I'll do that again. So that gives me the second sample. Probably I'll do the same thing 100 times. So each time I'm going to get 20 different numbers, right? So this is one of the uses where so basically what you're doing is you want to generate a random number, right? Now, how does a system generate a random number? Because system is always fixed, right? How do you, so random number generation, there are a lot of ways in which it is done. So, but one of the ways is using a certain combination of the current date and time, right? So let's say you're noting down the date and time right now, and you are changing it in some way, and you're generating a random number. 5 minutes from now, it's going to be a different time at least. So that combination of date and time can give you a different random number. So that's where it's starting. There are a few other steps which are done on that date and time to give you so many more random numbers, but that's where we begin with. Okay. Another thing, so this was one example where you might want to use date and time. Another example is, so let's say, so currently whatever steps we are doing, you can see that they give you an output instantaneously, right? You run it right now. So if I run this thing like right now, it doesn't take long, right? Not even a second. But as you deal with more and more data, it is possible that maybe your tool, your command, maybe it's going to run for 2 hours. It's possible. It's very, very common. Okay. So you would like to keep a timestamp on it, that you started running it at 6 p.m. today, and at 6:30 p.m. it's did the first step. At 6:40 the second step got completed. At 7 or 15 the third step got completed, and so on, right? So at those point of time, so it's basically you're taking like a snapshot of the time, and then you're just noting it down in the output, something like that. Okay, so these are just a couple of examples where date and time may be used. And other than that, you always, you are working with the calendar, you may want to see uh, which day it was 5 years ago, right? Anything. So all of that is going to be used. So we'll just take a look at how R works with dates. Okay. So first of all, how to get the current date and time. So that's going to be your system date. So sys date. And again, R is case sensitive. So you need to remember that where are the capital, the uppercase and the lowercase alphabets. So in system date, capital S and capital D. And in system time, so that's going to be capital S only, right? It's going to give you the local, whatever your system has been synced to, whichever time, it's going to give you that. And then, so currently we are dealing with two types of data, right? So one is numeric and the other is character, right? So let's say if I'm writing a date here, let's say I'm copying this one. Okay. Okay, by the way, before we begin with this, so a date is comprised of day, month, and year, right? And you all know that, so in India, we are following the format day, 2 letters of day, 2 letters of month, and then mostly 4 letters for the year, or sometimes even 2 letters for the year. Okay, so that's the format, but the format can be different. Somewhere it is month, day, and year, somewhere it's year, month, and date, and something like that. Okay. So, so R by default follows this format, which is year and month and day. Okay, this is the what is called as the default format. And right, so this is what you saw. Okay, this one. So it's year, month, and date, whatever you want to call it. So now let's say if I've written this here. Okay, if I just press enter, it's basically printing that. So can you tell me, so I have not come to that point yet, but you would remember from the lecture, if I want to find what format, what type of data this is, what function can I use? Do you remember? This was covered in the last lecture of this week. Also was mentioned a little, I think the first or second week. Mode. Yeah. Okay. So if I just enclose this in mode, right? This is what I'm doing. So I'm feeding this. So it's going to give me character, right? But now let's say I enclose this thing, mode as date. So you see what it's doing? So it's in double quotes. Okay, so it's a character. That's fine. And now I'm saying converted to date. So it is treating it as numbers now, which is not entirely incorrect. Okay, it is date, it is a different thing, but you would consider date to be more like numbers than character. Okay, so nevertheless, so anyway, this is how R is reading dates. It considers it to be a like a numeric variable, numeric data, right? And so now you see, if I just print this as it is, so this is how R is saving, right? Whatever I fed it, it's just giving me the same thing. So just by looking at it, you won't really identify that it's a date. So it's four letters, four positions for the year, then month, and then the day. But now let's say in case instead of the hyphen, I'm using these slashes, right? So if I run this, so you see I entered slash, but I got hyphen. So by default, R is going to convert anything which looks like a date. When it is to be converted into the date format, it's going to consider year, month, and day. It is able to recognize that slashes can be there in the input, but I'm just going to replace those with hyphens. Okay. Likewise, if sometimes you may not use 0. Okay, let's say if it's 05, I can just write 5. Or here, let's say if it was 03. So basically I'm writing 3rd May. So if that was the thing, so you see again it's converted it to, so it has to get into the for the year, 2 letters for the month, and 2 letters for the day, right? Now so again, so okay, which one's this for? Yeah. Okay, sorry. So now you see, now here, so I've made, what changes I made? I did slash instead of hyphen, that it can accept. I made like 2 letters for the month, and instead of 2 letters for month and date, I used just a single letter. That also it accepted. But now I switched the position of the month and day. So basically I'm writing day here, but you know, right? It expects to get month in the second position, and it says, okay, that there cannot be 30 months. So definitely the format is not correct. Yeah. So it's going to give you that there's some error. So now let's try one more thing. So maybe instead here, let it be the same number. But now let's try to keep it 23. So 23, 30 May 23. If I enter this, so now you see what it did here. So so it can accept 23. That's not an issue. But it said, well, I don't know what 23 it is. Okay, it could be 1923, right? 1223, 2023. So it doesn't know. So it's just going to say, okay, if nothing is there, that it means 00. That's what it did here also, right? It just added 0 to any of the positions that are empty. So this is, so it so won't give an error, but also not necessarily the correct output. Yeah. So you have to be just a little careful with this. Okay. Now, so I will show you just one more thing. So when I write as dot date here, so it's going to open this the help page. And now if you see there's something in this format, right? So it says percentage capital Y hyphen percentage small m hyphen percentage small d. And likewise the same thing, but instead of hyphens, there are slashes. Okay, so think of this percentage as any number of letters. Any number of letters for the year, capital Y indicates year. Then any number for month and any number for day. And by any number in Y, it means it can be 1, 2, 3, 4 letters. For month, it can be 1 or 2. And for day also, it can be 1 or 2, right? So now let's say I actually want to sort of write it in this format. So year, day, and month. Let's say this is what I want. So what I'll say, I will write what I want to convert. And as the second argument, I'm going to tell it that I am giving it to you in this format. This is the input format. So I'm telling you that my first set, the first part here is year. The second part is actually day. And the third part is month. So it did not have this format in its sort of dictionary. It only had this format, year, month, day. But I'm specifying, no, I'm giving you it year, day, month. Okay. Now, I think this part was not covered in the lectures, right? But this is just a very minor part. Just keep it in mind. It's going to help you. And if you don't think it's necessary, you can just forget it after the class. Okay. Right. So if you want to change a format, if you want to give it a different format, so now you see what it did. It converted it back to what it recognizes, which is correct. It will give it you back in the format it learns, it knows, but at least it's able to read it now. It's not giving you an error. Okay. And now you see, if instead here, if I would have given just 2 letters, so you remember it was making this mistake here, right? Adding zeros. So what I said, instead of writing capital Y, I gave it small y. So now you see, so it's taking up the current century. Okay, so it's taking 20 as the current one, which is better, right? And likewise, I can also change it to like using hyphens. So if I'm giving hyphen as the input, it's able to take that, right? So both slash and hyphen, right? And of course, I can also convert. So let's say if I write today's date, so today's date, it's 12, and I'll say September is 9, and then 23. So this is how we would normally write the date. So to read it, what should I write? What format have I written this in? What should I write here? Percentage what, hyphen slash, percentage what? So basically, I want R to be able to read this. So I'm telling you, what am I giving you it in? What are each of the each of the 3 things here indicate?
Percentage D, percentage M, and percentage N.
And hyphen slash, what should I write?
Same slash.
Slash, okay. Then percentage M, percentage small y, capital Y.
Small y.
Small y, right? Because I'm writing, so first it's for D, then it's the month and it's year, and I'm saying that I'm giving just the last 2 letters. It's not 0023, but it's the current century. So that's 20, like 20 and this. So if I write, so it's giving me that, right? 12th September 2023, which is correct, right? So great. So this is how, so it can be slightly complicated, but okay, this is how it is. And now that we have learned that we want to, that this is how R is going to read date. So we can also make sequences of these dates, right? Earlier we made sequences of numbers. So since we just saw here that, where is it? It is, after all, treating it as numbers. So we can do these sequence generating things on this. All right. So, but it needs to be considered as a date. This is a character, right? So this is not going to be considered. So I'll just tell you what all things this is. But anyway, this here, it's throwing an error. Okay. And so basically the first argument here is from. If nothing is specified, the first argument is considered as from. Okay. So it says that from must be a finite number. It has to be a number. Okay. So anyway, so that's not going to work. So I am actually giving it this date, 30th May 2023 as the date. And so now you can make changes, you can make sequences, and you can say that you can have it by years, right? So which is like, so again, any of the formats, hyphen, slash. So likewise, like just we had seen in this one. So you're giving it from, you're giving it by, and you're giving it the length. So yeah, so from, by, and length. So you're giving the starting date, you're saying change it by year, so one year up and down, and then length, so 8, like this. So if I do this, so you're getting 30th May 23, and it's by years, it's going to be, years by default is going to be mean positive. So 23, 24, 25, and all these years, right? If you do slash, then also you're going to get the same answer, right? Because internally it's going to convert everything into this format. Year, hyphen, month, hyphen, day. Okay. And likewise, you can also do it day-wise. So it's going to be 30th May, 31st May, then 1st June, 2nd June, and so on. Give this a try with the leap year. So, something around the 28th, 29th Feb in 2020 or in 21, and you'll see that, it's treating it differently. It's incorporating the funda of leap years. And then this was by years, by days, and likewise you can have it for months. So you can have it 30th May, 30th June. Again, try and see what it does in for a month which does not have 30 days. So we can actually give it a try. So we can actually try this, and we can just see that instead, if I'm going to write -1 month, so it's going to go back. Okay. So you see 30th May, 30th April, 30th March, and this is what it did. Yeah, 30th Jan, and of course 30th Jan was not going to be there. So 30th February was not going to be there. So it was 20th Feb, 29th, and instead of 29th and 30th, it said 1st and 2nd of March. So some calculation, however it does. So that's happening here. And yeah, likewise, yeah, this one I already had. Okay, so it's the same thing, right? So you can have it. I think 2 should also be possible, right? You're skipping alternate like that. So you can try all of those combinations. Okay. And here, like we did it with from, you can change any of these to also, and that will also work. All right. So, okay. So that's with how time and date can be used, mostly focusing on date here. And so we've seen with numbers, right? Sequences with numbers. So that's mostly what is used. But if you also want to work with sequences of alphabets, so basically all the A, B, C, D until Z, it can be a little cumbersome to write everything down, right? Because that is fixed. That sequence is fixed. So there are just these two. Any question?
One interruption. Yeah.
Yeah.
Can you change the format of the date, like output date?
Okay. So, as far as I know, not through this as dot date function, but mm, no, yeah. So yeah, probably not. But I think through some way it may be possible. Maybe not directly. Like there may not be a very straightforward function like this, but some way it could be possible. But I have no idea about it, so I'll have to check. Yeah.
Okay.
But I mean, it's a reasonable question because let's say you actually want to save the output in some format. Let's say the way we write the dates, right? Day, month, and year. I want to write it in that format. So yeah, I mean, should be possible, but I'm not sure if it's straightforward.
And
Yeah.
in input also, can we give like that months and all? Can we give in letters like
Oh, yeah,
Jan?
yeah, yeah. I think you can. Uh, yeah, I missed that. So let's try. So let's say I'm giving, I think I read it somewhere. So let's say 20 Jan 23, something like that. It's not converting like this. Can I do it like this? Not this as well. Not this one. Okay, wait. As dot date. Hmm. Format, try format. Hmm. Hmm. Yeah. Okay. So here you see there's a percent B written here, right? So basically, I'll just write it here. So this is in the format. So let's say percent day, and then I have hyphen, and then percent B. Not sure what the letter B here indicates. And then percent small y. Yeah, that's working, right? Yeah.
Yeah, thank you.
Yeah. Okay. Thanks for asking. Let me just put it here. Okay. So so as I was saying, for numbers, it's up to you what numbers you have to write, but alphabets are well fixed, right? So there are these two already inbuilt data vectors for alphabets. For the lowercase, it's letters all in lowercase. For capital ABCD, it's letters and capital letters. Okay. So these two, right? They're there. Now you see that they are not here in the environment, but it is almost as if they are in the environment, right? So this is again like an example of sort of reserved words. So it's often advisable to not use reserved words for anything because so mostly what you're doing is you're going to overwrite these. But we are not like I am not entirely sure if it always overwrites it or it somehow sort of saves it somewhere. We are going to see that example today. So I think last week's assignment, the first question um, is sort of making use of that aspect of reserved letters. So we'll just see that. But yeah, anyway. So, okay, so these two letters are there. And again, this is like any other data vector. You want to extract the second and third element, you'll write it in square brackets, C 2 comma 3 or 2 colon 3, something like that, right? So you can do that. So that's fine. Okay. And then so we saw sequences and all, and currently mostly what we have seen is where you mostly have unique letters or unique numbers with you, unique dates. They're all in a particular format, but it can so happen that you want the same value to be repeated multiple times. Okay, so in that case, so we'll call them as repeats, and the function that we'll use is rep. Okay, so now, simple thing, you have a single letter or a single character that you want to repeat sometimes. So you don't bother about what you're feeding it, but you're just writing the first that letter. Okay, likewise you can also have it with numbers, right? So 2 comma, let's say 4 here. So it basically means the first thing is going to be repeated as many times as the second argument here, the second number, second value. Okay, so you can writing high 3 times, you're writing 2 4 times. So that's there. And then it can so happen that instead of repeating one thing, you have many things to repeat. Okay, you can have multiple things to repeat. So now you have two options. Okay, when if I say I want to repeat apple comma banana 3 times, so you see there are these two options. You can have apple banana, apple banana, apple banana, or you can have apple apple apple, banana banana banana, right? So they're both repeat in some way or the other. So what is the difference between these two? So in the first one, you're taking this as a single group. So this is your input, and you're repeating this 3 times. So times. So this is 1, and then this is 2, and then this is 3. So that's one way. And in the other one, you are repeating each of the things 3 times, and in that order. So the first thing here is apple. So you're writing apple, apple, apple 3 times. And then the second thing here is banana. So you're repeating that 3 times. Okay. So these are the two ways. And so again, we have discussed that sometimes there are default arguments, sometimes there are positional arguments, wherein you don't need to specify the name, you're not specifying, but it still takes it as something. So if you don't specify anything, it's going to take it as this one, the first one, which is times. So you're considering the whole thing as one entity and you're repeating that, which is a more intuitive way to do. So you have a chunk and you're repeating that chunk many times. But to be unambiguous, to not have any confusion, it's going to be recommended that you write times or each. Okay. And sometimes you may want to do both the things, right? You may want to repeat each of the things sometimes and then repeat the whole thing multiple times. Okay, so let's say if I have to do that, what is the order that's going to be followed? So first it's going to do each. Okay, this each part is going to be executed first. So it's going to say apple, 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 and then banana, banana, banana. And then it's going to repeat that twice. So the first part and then that part repeated. And it doesn't matter if you're writing times first or each first, because once you've specified it's each, it's going to be there. Each of the things is going to be there 3 times, right? So the output of this one is also going to be the same. Okay. So named arguments, it doesn't matter which one you write first. They are not position dependent. Okay, that you know, right? So for example, in this case, when we are saying from to by, so if suppose I just write by is equal to minus, let's say 0.3, and I write 2 is equal to 7, and I write from is equal to 3, right? I would still get the same answer, okay, which I got here. Okay, it's the same thing. So again, so named arguments are not position dependent, right? This is what I say. Whatever order you write it in, there's a particular inherent, it's going to read it in some particular format that's going to be there. And that's the case here. So first each is executed. executed, and then times. Okay. All right. So that's one thing. Another way in which, so it's also possible that you may want to repeat each of these things different number of times. So you may want to repeat banana different times, like apple different times and banana different times. Okay. So now in that case, you see what is happening here, right? So now you see, even though we have given it times, it's not each anymore, right? So it's basically equal to times, right? What would happen if we do this? It's going to give an error. So, so whether you specify anything or not, this one is taken as times. So what it's doing is, it's saying, so you've sort of split it now. So even though it looks like a chunk, but it's working as each. Okay, so you are repeating this 3 times and repeating this 5 times. Okay. Um, Now, can you think what would this do? So here, the length of this thing, the length of the things to be repeated is 2, and the length of how many times they have to be repeated is also 2. Here, the length is 3, and here the length is 2. Do you think? So, apple is going to be repeated 3 times, banana is going to be repeated 5 times. What's going to happen to orange? Or is it going to give an error, warning, incorrect output? What do you think? Just a wild guess. Any idea? It's just make a guess. No? Okay, I'll just run this then. So it's just going to give me, it's giving an invalid argument. Okay. Yeah. So that's what we would have thought, what we have seen initially, that the shorter length is, used, it's sort of repeated. But in case of rep here, it does not accept that. Okay. So which is good in a way, right? So that it's not going to be ambiguous. It's not going to do something which you did not want it to do, right? Likewise, in case of the opposite case also, if you have certain number of elements and you're giving it more times here, it doesn't make sense. Okay. Right? So this is something. So okay. So now one more thing here. So if I open this function here, so you see this function has times, length dot out, each. So these are the 3 things it can accept. We've talked about length and we've talked about times in each, but we have not talked about length or length dot out. Same thing. Okay. So when we have like the like, so you've seen each. So in case of a single element, times in each is going to behave the same way. Okay. Because it doesn't make a difference. And length also gives you the same thing. So basically length is a constraint on the length of the output. So normally what we are saying, these times or each, this is a constraint of how many times you want to repeat the input, right? But here you are constraining the output. That output has to be of length 5. So now basically what I'm doing here is, so I'm saying repeat this thing, but only repeat it. So take it again, take it as a chunk. So times, but repeat it only until the output has a length of 5. So you see it repeated it once, repeated it twice, and that's it. Okay. We can just check what is going to happen if I say times is equal to 3. So again, it gives the same result, right? If I say times is equal to 4, then also it's giving me the same result. Because even though times is saying that repeated 4 times, so apple, banana, again, 3 more times, but it's saying it's just going to constrain it when the output has 5 elements. That's it. Yeah. So does that make sense? So again, there are specific cases where you might want to use it. You can have, like multiple responses from people, but you're saying, okay, I'm going to like sort of cut it at 5 responses per person or something like that, right? So this is where such things can be used, but it's both ways. It's good to know it before you're using it, and sometimes you'll only learn about it when you are using it. Okay, so fine. So that's this. One more thing. So I think it was last week or last to last week that we had seen that uh, a matrix is actually a vector which is read column wise, irrespective of how you made the matrix. It's not relevant whether you've made the matrix row wise or column wise. A matrix, once the matrix is made, once you have a matrix in front of you, if another command, another function is going to read the matrix, is going to read it column wise. Okay, so we'll just take an example of 2 matrices here. So this is matrix M. Here I'm writing it row wise, and this is another matrix. I'm writing it column wise. Okay, so if you see here, I'm feeding it the same vector, but the matrix looks different. It has the same dimensions, right? It's a 3x2 matrix, 3 rows and 2 columns. But if I say that I have to read the matrix, if some other function has to read the matrix, it's going to read n as 1, 2, 3, 4, 5, 6, but it's going to read m as 1, 3, 5, 2, 4, 6. This, just keep this in mind. So why we'll be using this? Why would anything read a matrix as a vector? Because so matrix, while it is a 2-dimensional object, you will see sometimes. So if you see here, this functionality of matrix. So you see here, it says it's number. It has 1 to 3 rows. It has 2 columns. But you see, this is the order in which it's written. Okay. So matrix, if you have to write down a matrix, you will write it as a vector. And therefore, since it is a vector, you can do any of the vector functions. So for today's class, we'll just say that you have the repeat function here. So you want to repeat the matrix elements 4 times. So if you're repeating the elements of 4, it is 1, 3, 5, 2, 4, 6. That's going to be repeated 4 times. Okay. So, and again, 4 here means times. So 1, 3, 5, 2, 4, 6, 1, 3, 5, 2, 4, 6, and that's 4 times. Yeah, so I don't exactly remember what C-bind and R-bind was used for, but we can discuss C-bind and R-bind in general. We had discussed that in one of the earlier lectures, but if you want, I can give a recap of that. Will that be okay? Because I don't exactly remember where he had used C-bind and R-bind. But basically, C-bind and R-bind are two, you can make a matrix or you can expand a matrix. Yeah. Okay. So let's take an example of these 2 matrices here. Okay, I'll just wrap up these 2 things. So again, here also. So, right, you can, it's treating it as a vector, the vector which is written here. And like any other case, you can also do each. Each is equal to 4. So it's just going to repeat 1 4 times, and then the next element, and so on. Okay. So now I'll just write R bind and C bind. So now, so you have these 2 matrices here, right? Now I want to bind rows. So R bind means row bind. So it means, these are the three rows here, and I want to bind row with rows. Okay, so that's, or rather this way. So row below rows. Okay, so if I write R bind M and N, so it's going to give me a longer matrix, right? These first three rows belong to M, next three rows belong to N. Okay, and obviously now if I change the order, that's going to be different. Okay, N comma, what happened here? Sorry. So yeah, if you see these two things, this one and this one, they're different, right? Because the matrix that you mentioned first comes first, below it comes second one. Now, what is the constraint on R bind? The columns need to be the same. Number of columns and their all names also need to be identical. They need to be the same. Okay, because I have, let's say, let me add another matrix to this discussion. 1, 2, 3, 4, and just fill it. Okay, so now this P matrix that I've made here, it has 2 rows and 2 columns. So can I add it below matrix M, or can I add it to the right of matrix M? So this is M, it's a 3 by 2 matrix. P is a 2 by 2 matrix. So I want to join M and P. So will that joining be one below the other, or will it be left and right adjacent? Just think about it. If you have a rectangle and you have a square, okay, can I fit it like this, or can I fit it like this? Tell. Just unmute yourself. Side to side. Okay, so let me draw that. So my M matrix is a 3 by 2 matrix, right? And P matrix here is a 2 by 2 matrix. So this is M, okay? This is what 3 by 2 means. And this is basically my 2 by 2 matrix. So if I fit them side by side, the first row have 4 elements. The second row is going to have 4 elements. But the last row will just have 2 elements, right? It would not work. A matrix, a 2-dimensional object, needs to have the same rows for all columns and the same number of columns in each row. Okay? But what I can do with this is, I can have it one below the other, right? Yeah. Yeah. So just, it's always better to draw and, understand. It will just take you a few seconds extra, but it's going to give you the right answer. Okay. So what we are doing here is, so basically I'm joining rows and I'm joining it row by row. So rows binding to row. Okay. This is not very intuitive sometimes, but yeah, I'm row below row. So R bind. Okay. So this is R bind. Now, let's take another example. Now, in case I have a single column data frame, single column table, or single column matrix. Forget the other names I used. You'll learn it in a few weeks. Single column matrix. Okay. Because I'll have to draw otherwise a lot of them. So I'll just draw one. So I cannot put this below here, but I can put this adjacent to it, right? So like this. Okay. So this is C bind. Okay. So I'm binding columns. I'm adding a column. So when you're doing row binds, you increase the number of rows. When you're doing C bind, you increase the number of columns. And therefore, in row bind, number of columns have to be the same, right? This and this need to be the same. And in C bind, number of rows need to be the same. Okay. So, yeah, so this is where we were. And right, so in R bind, you can do M comma P here like this. This is your M, this is P. But now matrix P cannot be used as C bind, right? Yeah, most welcome, right? So likewise, M and P, you can also do a C bind on them because so this is going to be C bind. Again, number of rows, names of the rows has to be the same. So we saw briefly how to change the name of these rows. So I won't go into it a lot right now. In case we get time at the end of today's class, we'll go there. But you can just refer to the last lectures if you want to change the names of the rows and columns. But again, that is going to come in one of the upcoming lectures extensively. So we'll take it then and there, right? So you can also do a C bind here. So basically these first two columns were your matrix M and the next two columns were matrix M. Okay. So that's the second part. Okay. So next up we come to two very like synonymous almost words, sorting and ordering. Okay. So so let's take these two vectors. One of them is a numeric vector and the other is a character vector. Okay, 9 elements, 7 elements. And so now you would want to, okay, I'll add a third word here, arrange. Okay, so you want to arrange them in a particular order. You want to sort them in an order. So we use these terms interchangeably, but with respect to R, we'll take a look at two of these, sorting and ordering. So sorting is basically what you think of doing intuitively. You want to make a particular, you want to arrange them in ascending and descending order. Okay, so by default, ascending order or increasing order is there. So you'll start off with the smallest number here. So here it's going to be -4, and then -1, and then 0, 2, 3, 3, 6, 8, 10, like that. Okay, so if I do sort, so that's going to give you the output. If again, the option here is to specify decreasing as true or false. So by default, decreasing is false, right? So if you see here, so question mark sort. Yeah. So, okay, basically, so what I've done is, so when I wrote question mark sort, sometimes the same name function can be available to do multiple tasks depending on what is the input. Okay. So here it says, now the description is the same. It's going to do the same task, but it might do some different functions. So you can see it says it's in the package BioC generics. Here it's in the base package. So this is something I had installed. I'm doing some work for that. So basically I want the one in the base package. That's the basic task. That's what we are doing right now, right? Simple sorting, nothing fancy. So I click on this sorting on ordering vectors. So sort, and by default, decreasing is false. Okay. So if I do decreasing true, then it's going to give me in the descending order. So decreasing order is true. Okay. And this same thing you can do for alphabets. So again, in case of alphabets, ascending order means you're going from A to Z, and descending order means you're going from Z to A. Okay. So if I do B, that's going to be increasing. And then when decreasing is true, it's going to be from Z to A. Okay. Now, so yeah, that's sorting. So, but now, so what you're basically doing, if you see what is happening here, what R is doing is actually it's seeing, okay, which is the, so let's say when we are doing the ascending thing, so it's finding which of them is the minimum. Okay, which is it? That's -4. So you put this at -4. Put what? So you're identifying the position of the lowest. You're calculating the minimum, which is -4. So, right? It's then saying, okay, what is the position of -4? It's 1, 2, 3, 4, 5. Okay. So you're putting the value which is at position 5 first. That's what we are doing here. So we are using fifth value first. Then what's the next one? It's -1. So which is 9. Okay. So ninth element, fifth element, ninth element, then sixth element, and then you have both the first element and the eighth element. Okay. So that basically is like first comes first and then becomes eighth, something like that. So what is happening here? Instead of writing the actual values, you're saying the position of those values. So these ones, but instead you're searching that where was -4? It was at position number 5. Where was -1? It was at the last, which is ninth position. Where was 0? It was at 1, 2, 3, 4, 5, sixth position. So if I'm right order, that's what it's going to give me. So fifth, and then ninth, and then sixth, and then seventh, and then eighth, and yeah, 7, 1, 8, and then yeah, 3, 2, 4, like that. So that's what order is telling you. It's basically telling that. So now can you think if I have this with me? So these are the positions of elements of A. So if I want to get the output of sort A from order A, how can I do that? I want to get the output that I got in sort A, but let's say I'm not able to use the function sort A for some reason. I can only use order A. So how do I use order A and A to get the output of sort A? So what do you use if you want to extract one element from a vector? What do we do? If you want to extract any position, value at any position from a vector, what do we do? This you know, right? You've seen this. Square bracket. Perfect, right? So that means, so let's say I have vector A and I want to extract this thing, fifth position. So I'll just write 5 and I'm going to get -4, right? If I write 9, I'm going to get -1. Now, if inside, if I write order A, which is basically I'm writing this thing inside of A. And if I write sort A, I'm getting the same thing, right? See what's happening. So in sort A, what it's doing, it is sorting the values. It's giving you the sorted output. Elements sorted out. And here what is happening is, I'm saying order A, order the elements of A, and give me the positions in which they are going to be used. And I'm feeding that position to A, so it's rearranging A. Okay. Was this clear? Or you should I draw it? Yeah. If you don't say anything, I'm assuming it's clear. Yep, clear. Okay, cool. All right. And then this we've seen. So mode, basically it's to check what kind of information is saved. And there are actually a few types of inputs, types of data that R can recognize. Okay. So we have mostly seen, where is it? Yeah, numeric, right? We've seen numeric, and we've seen character. Okay. We have seen function also, right? You defined functions, you used functions, and there are a few others. Okay. So one more thing we'll see is list right now. There are a few other things. We won't go into it. There's no point in discussing that. But it's the kind of information it's storing. It's not the structure of that variable. It's not telling you if it's a vector or if it's a data frame like that. Okay. So A here, that was a vector, but it's a numeric vector. Okay. And likewise B here, that's also a vector, but it's a character vector. So it gives you character. M was a matrix, but it's a numeric matrix. So again, it gives you a numeric. So both A and M return numeric. Okay. And you can actually check. So I'll just write. So we've seen, right? Whether you define a function or whether it's one of the inbuilt functions, right? So let's say print. Print is an inbuilt function, right? So yeah. So you see, it's returning it as a function. Okay. You can actually feed, I think, you can feed mode itself to it. So that's also a function, right? So these are some of the things we'll see. List is treated a little differently. And so yeah, so you can check what all it is, but we won't go into it right now. We've not discussed any of that. All right. So just sometimes it's useful. So most of the application of all of this is mostly so that, let's say you have asked the user to input number, but what if the user is entering letters? Okay, or the user has entered it in double quotes, so that becomes character. So you can just check if mode of the user input is equal to numeric as you expected, then you proceed with working on that data. But if it's not, then you just sort of give an error to the user that please check the kind of data you entered. Please correct, like check the input, something like that. Rather than R giving you an error that incorrect input. It's better that you are correcting from your own end. Okay. So this is where these things can be used. Okay. So then the last part of this week was about lists. So the best way to understand what a list is that it's sort of a multi-vector. It can hold multiple elements. So how do we define a vector? We say that a vector has multiple numbers or multiple characters saved in it, right? It has positions. So first position, second position, third position, and so on. But normally each position in a vector is just going to be a single number or a single character. But in case of list, you can have um, several of you can have individual elements. So okay, so instead of explaining, I'll just show you something. So I'm going to define, so instead of using C, you're going to use list. Just remember it that ways. And within C, you used to write, in double quotes or just numbers. But here you can write more complicated stuff. So each of the elements of a list, okay, can be more complicated things. They can be very simple things. They can just be numbers or they can be complicated things. So let's start off with this one. So I'm defining L3. So I'll just write L3 here and let's see what L3 is storing. So this is what L3 stores. So it says at the first position, it's storing something. At the second position, again, something. At the third position, it has this. Fourth position, it has this. And at the fifth position, it has this. Okay. So, So now when we talked about vectors, when we set position, it was always a single square bracket open, single square bracket close. But in case of list, you have double square brackets. Okay. So, for example, so L3, and you want to extract the first element of L3. So you'll write 1 in double square brackets, right? So this is what we gave it. We said the A is the first element. So we got A, right? Right? Likewise, you can extract the fourth element. Sorry. So this is your fourth element here, right? This was a matrix. Now, another way in which you can do that is, so now let's say you have this one here, so L3, you took the first element, and now out of all of these, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say I want the seventh element here. So once this is done, after this, it becomes a normal vector for you, right? This vector, I want the seventh element. So if I run this, I first take the first element of the list. That gives me a vector. I take the seventh element of the vector. Okay. So that's how you define a list. It is very, very similar to a vector. Okay. Now here, if you see, here you just had these numbers, right? You can also, instead of numbers, you can have names. Like numbers will always be there. It's going to be always first position, second position. That's always going to be there. But you can also give names, right? So let's say I'm saying vec1 is A. So here I just gave A, right? This A. But here I said, call it vec1, call it vec2, mat1, mat2. If I do that, and if I see what L4 stores, so now you see it's storing these names, and the way you can actually refer to these names is using the dollar sign. Okay, the dollar sign is going to come more often from now. As you get more and more complicated structures, dollar sign is a very it's a relatively simpler way to extract information based on names. Okay, so again, if you forget about the names, if I want to extract the first element, which is A, I can still extract it using the same thing as before. Okay, right? I can still extract the fourth element with this. But I can also extract the first element by its name. So the first element's name is vec1, and I can extract it using a dollar sign. So you see this one. So you see this thing here and this thing here, same thing. And there is one more way to extract the same information. So in double square brackets, I write the name vec1. That's also going to give me the same answer. Okay. So again, a list is a complicated format of a vector wherein each element does not have to be simple. Now, it doesn't have to be a simple number or a simple character. It can be a vector in itself. It can be a matrix, or it can be a simple number. So as in vectors, you want to extract a particular element, you can refer to that element by its position. It's just that now the position has to be referred to using double square brackets. Okay, right? Because see, in case of vectors, so let's say when we were talking about vectors, they were always by the single square bracket, right? So this is 1, 2, 3, 4, 5, and so on. But now when I'm writing this, you can already see that it's referred to with the double square bracket here. So whatever you want to extract, you can refer to it with the double square brackets, and then it becomes your same normal thing, right? So for example, I'll just write L4 here. This gives me a matrix, right? Now, if from this matrix, I want to extract the element 2, so I can just say it's my second row, first column. So it's going to give me 2 here. Okay. So once you extract a particular element, that element becomes just like your normal matrix or normal vector. So you can extract its right. So you can extract its elements just like you normally do. And if you have given names to these elements at the time of defining the list, then you can also refer to any of the elements by its name, either using a dollar sign followed by the name, or instead of the number, you're writing the name in double quotes inside the double square brackets. Okay. So with that, we end uh, the discussion on this week's topics. I do have a few practice questions, but do you have any question before we go there?
Where do we use this data practically?
Sorry,
It's
say
in,
that again.
yeah, I mean, so what's the practical use of this list? So,
Okay. So let's say, so we defined two matrices here, right? M, N. Okay. Let's say I have 100 matrices that I want to work with. Okay. And I want to do something very similar on each of them, like finding row sums, call sums, checking something in that. So I would like to do it through loops, right? So, and we just saw in in loop, you're generally iterating over, we wrote, right? For I in 1:4. So I will go 1, 2, 3, 4, and then those 1, 2, 3, 4 can be uh, indices of a vector. First index of the vector, second index of the vector, third, fourth. Likewise, those 4 can also be indices of my list. And once I go over it, I'll say that, okay, at every position of my list, there's a matrix and I want to do some task on each of them. So this is going to make that simpler. I don't have, like, whenever you have repetitive tasks, you can just combine all your inputs together in a particular order and you say, do all the tasks on all of them one by one.
yes,
Yeah.
and one more,
Hmm.
yeah, how to find the statistical mode?
Statistical mode. Okay. So let's say, so let's take this example here. Okay. A. So we know that the mode here should be 3 here, right? So I am not sure if there's a simpler way, but there is this one statistical mode in R. So there's this function called table, and table is basically going to give you the frequency distribution. So if I write table A, so it's telling me -4 is one of the elements, it's coming 1 times, -1 comes 1 time, and 3 comes 2 times. Okay. So looking at the table, you can see that, okay, out of all the elements, 2 is the maximum. And this is for number 3. So here, the mode is going to be number 3.
Yeah, clear
Yeah.
now. But if we have a larger data, then we cannot
Yeah.
compare each other.
Yeah. So there's a longer way through it. So what you can do is you can say that you can find the maximum of this, and then you can say whichever position the maximum is, you give me the corresponding top value for it. It's just a couple of more steps. I will refrain from explaining it at the moment because it's not straightforward. There are a few things that we've not yet seen in R. So it's just going to make it complicated. But this is the starting point.
No, got it.
Yeah. Okay. Yeah. So you can automate everything in R. Okay. For sure. But it's going to be, you'll have to write as many things. And the way to do it is you think about how you are doing. Try to break down what you've done in just a second. Try to break it down into smaller steps. So what I saw here was I saw the number 2. Why did I say number 2? because it's the maximum of this list. Okay. So when it's the maximum, I take the max, and then I see the corresponding number here, and then that number is my output. So I broke it down into 2, 3 steps, and I somehow need to write all those steps in R as R commands. Yeah.
And so somewhere I saw like levels. Level means this is the same thing it will do, I think. Levels.
No. So levels, as far as I know, it has something to do with the factors. I don't think levels of its arguments. Yeah, so it's something to do with factors. Um, so we'll discuss it probably some other time. So that factors is not being taught right now, right? It was just referred to in this speak. I think it was just touched upon, but it was not explained, right? So let's leave it for now. But no, levels is not going to help you get the mode. It
Okay.
it might use it might help indirectly, but again, it's going to be through this table form command only. Without table, it can't be done.
Oh,
Yeah. Okay. All right. So let's take a look at some practice questions. Okay. Yeah. So there are so you know this, right? This I think you'll be able to do. The difference in the output of rep command when it says times is 4 and each is 4. You can just tell me orally. There's going to be too many things to write. But can you just tell me orally? Maybe I can just take this.
yeah, times will repeat the whole sentence 4 times. Each will repeat each element four
Yeah.
times.
Yeah. Good. So, uh, so this one here, it's going to be 50, 49, 48, 47, 46. That's one time. And then 50, 49, 48, second time, third, and fourth, right? Like this. And this one here, it's going to be 50, 50, 50, 50, like obviously separated by commas, then 49, 49, and so on, then 48, 47, and 46, right? Yeah, perfect. Great. Okay. So this one's just you need to be careful. And so is the number of elements in the output of each of them the same? Number of elements in the output here and the number of elements in the output here. Is it the same or is it going to be different?
The same.
The same, right? So um same number of elements, right? Yeah, same. Because here it's sort of so 50, 49, 48. So this is yeah, 5. So this is 5 into 4, and this is sort of 4 into 5. So it's the same, right? Okay. Good. Next question. So what will be the outcome of the command rep -5 to 2, 2 comma 10, 2:10? Remember how this works?
First element will repeat twice. Next later element will be means it will
Thrice.
repeat thrice. Yes,
Yeah.
it
Yeah. Okay.
continues.
Okay. Now I've just so although you will not have subjective questions in your exam, like as such, you don't have to write this. But if you type this in R, it's going to give you an error. Why? Because if you see number of elements here, it's -5, 0. So it's going to be 8 elements, and this is actually 9 elements. right? So this is going to give you an error. So this is a correct, better question, right? So both have 8, 8, and what you said is right. Okay, so basically -5, then -5, then -4, -4 3 times, and then -3, and then like this, and so on, right? So then the last element is going to be repeated 9 times. Okay, so that is correct. It's just a frivolous question. Okay. Okay. All right. So then you have a list. Okay. We just defined lists. X1 is double quotes high. X2 is double quotes 3 minus 5 plus 9. And X3 is something complicated. Okay. Now, before I actually go into the question, you can see that already you can see here 3 types of double quotes. This is starting is shifted to the left. This is straight. This is sort of okay, right? So you remember in one of the, I think this was week 1 itself, where it was discussed that you should refrain from copying this into R. Okay, so just a second. So if I copy this thing, okay, okay, I'll copy it later, but you'll see if I copy this, it will throw some error because it's not able to recognize all the double quotes. You can copy from R to any, text text editor, Word, Notepad, anything. But from here to R, you just need to be careful because you have different kinds of double quotes based on, they could be italicized, they could be straight, they could be curved. So it's just recommended that you should be careful with that. Okay. So now this question is using your knowledge of sequence, repeats, and list. Okay. So I would like you to resolve this final bit, whatever it is. And I hope, just you just check that all the brackets are correctly placed. So the way you check it is you should have as many opening brackets as the number of closing brackets, right? So this one is for this here, and then this bracket is for this one, right? So you have the closing brackets, opening brackets, they're all matching. So can you resolve what is x3 here actually? So again, how to do it is you are opening the innermost bracket first. So this is 2. So you have to go till 2 in length of 3. And when nothing is specified, it's going to be an increment of unit 1 that you assume. Okay. So, so can you tell me the output of seek 2 is equal to 2, length is equal to 3? Say that again.
2, 3, 4.
So this is 2. The last element has to be 2.
Okay.
After
Yes,
increment of 1.
Yeah, then -1, 1, -1, yes, 0, 0, 1,
Yeah,
2.
0, 1, 2, right? 1 to 1. Why did you say 1 to 1? So here it means that you need to have, so the way you can actually go about it is, why is this not working? Yeah, okay. Okay, so basically it means length 3. Okay, so you have 3 elements. The final element is 2. You have not been given anything. So you assume that here it was a jump of +1 and here it was a jump of +1. So you can think, so therefore it's going to be 1 and this is going to be 0. So this is the output of seek, this thing. Now let's solve the green bracket. So rep this thing, comma 2. And we know when it's just 2, it's going to be considered the whole chunk is going to be repeated twice, right? So it's going to be 0, 1, 2. comma 0, 1, 2. Okay. So this is basically your x3. Okay. And your x2 is equal to 3 minus 5 plus 9. And x1 is equal to, okay. These are the three things in your list Z. Okay. So first of all, tell me, is this the way you write? You refer to the name. So x3 here is the name of the third element. So do you think you can refer to the third element using this thing? Double square brackets, and in double quotes, you're writing the name.
Yeah, we can refer it.
We can write that. So this is correct. And this is what the output is. Okay. This. So it's going to give you something like 1. It's going to be 0, and then 1, and then 2, 3. Sorry, 0, 1, 2, like this. Yeah. And you remember, right? This 1 is actually indicating index of this one. So this is 1, this is second element, third, fourth, fifth, sixth, like that. Okay. What is the correct output outcome of the command Z in double quotes, sorry, in double square brackets 2?
Second element.
So is it going to be this, or is it going to be 7?
Only that. So double quotes.
Say that again. I'm not able to hear you.
Same thing.
Same thing. Why? Why not 7?
So double quotes. So
Double
it's
quotes,
character.
right? Yeah, that's the trick part. So if instead, if the double quotes were not there, if it was 3 minus 5 plus 9, it would have given you 7 as the output. Okay. And likewise here also. Okay. So here I've not added 2 square brackets. So this is just sort of, I just wanted to show you what is the outcome. It will be able to take this in. It's not going to give an error, but the output is going to be slightly different. So we'll just see what that is, but refrain from doing this. Okay. All right. Final question. I'll show you the output for the previous one in a minute, but before that, take a look at this question. So you have to generate a sequence of 3 dates year-wise: 1st July 2020, 1st July 2021, 1st July 2022. Which of them is going to be there? So the best way to do it is eliminate whichever one is wrong, right? So you can see in all of them some either capital and small error, or one of the arguments is wrong. So yeah, A is the correct answer, right? Okay. All right. So I think, yeah, so if we have time, even if we are not able to discuss assignments, I have finally figured out how to find the log of anything. I showed it to you in one of the other calculators last week, but I'll show it to you in the one which will most likely be given to you in your exam, if at all you have to use a calculator. So, okay. Where were we? So this question, right? So if I copy this in R, right? So now you see when I copied it, can you see this one got recognized as in white for some reason? This one looks very different than this double quotes. Okay, because normally if I write double quotes, they're straight, absolutely straight, like this one, right? But here they look all different. So I'm just going to replace them all with the correct double quotes. Okay. So that's Z here. And we've seen that, you can refer to this thing, sorry, like that. And if I do not write the 2 square brackets, so you see there's a slight difference here. It is able to recognize that it's third element, but it's still giving me dollar, that third element's name. Okay, so it's slightly different. So I will just recommend you to not do it. Whenever you're working with lists, always go for two square brackets. Okay, whether you refer to the index or you refer to the name, but use double square brackets. Okay, and yeah, after this we have the assignment solutions also. So okay, so this was your scientific calculator, right? That if you are to be given a scientific calculator, this is what will be provided to you for your exam. So you can check here, there's this option log yx. Okay, so now log yx means the first number, that's x. So that's going to be the number of which you want to find the log of. And the second number, y, is the base. Okay, so what you'll do is you'll write your number. Let's say I want to find 9 base 3. So I'll write 9. I'll press this. Then I'll press 3. And then I'll do is equal to. So I get 2. And you can just check that this holds the formula of log, right? So it's basically log y to the power, this answer should give you x, which is happening here. Like log 3 to the power 2 here is giving you 9. So this is how it's going to work. Log of any number, base the second number. So 9, press this button, the base number you write, and then press is equal to. Okay, I'm not sure if who had asked this question is attending today's session, but okay, this is done. This was long pending. And so I don't remember if we are actually still remaining to cover. I don't know what were the questions in these, what was the doubt in these questions. So let me know if I have to cover it. But before that, we'll just go into last week's assignment. Yeah, assignment 6. Are there any particular questions you would like me to talk about, or should I just go through all of them one by one? Okay, anyway, I'll start off with the first question. This is a little important. So here it's simple for loop, and you're saying for I in 11 to 13. So 11, 12, 13. So the loop is going to run 3 times. And it says print this thing. Now you see here 1 plus, this is okay. So I to the power 2 is okay. So I is a number and you're writing, you're finding the square of that number. So that's okay. But now here what you've seen, you see it's written 2i. It's not 2 multiplied by I. Okay. So I is actually a reserved word, and I is the imaginary number. So 2i is actually imaginary. Okay. So which is why this is actually, sort of outputted as it is. And what the rest of it is just there. So 1 minus I to the power 2. So when it's 11, it's 11 square, 121. 1 minus 121, that's 120. Minus 120. So minus 120 plus 2i, minus 143 plus 2i, and minus 168 plus 2i. So you can also check if I copy this and run it in R, this is what it's going to give you, right? Okay. So that's there, and this is the explanation given here. Here, actually, that's not going to be relevant, right? Because here you have written 2 multiplied by I. And if you remember here, this is 3 multiplied by I. And these double asterisk actually means to the power. Okay. So 3 multiplied by I to the power 2. And you first, like there is BODMAS, right? So you first solve the power. So you first find the square, then you multiply it by 3, and then you're doing simple addition subtraction. Okay, so once you solve it, either manually or you do it, copy paste this in R, you will get this answer. Okay. Okay. Then here, so you start off with y is equal to 5. And you're saying while y is less than 20, you do these things. So what are you doing? You're first doing print. Your printing C, MOC course are helpful. So this A is definitely not going to be the answer. B can be the answer. C can be the answer. D is also not going to be the answer, right? Because the first thing that's going to be printed is actually this. Okay, then you do y is equal to y plus 2. You're incrementing y. So it was 5. Now you've made it 7. Okay, and then you're printing this. So then you're going to print the alternate thing. So as it is, you can see that this is only turning out to be the right answer. But then you again increment it with 3. So it was 7, now it became 10. Now the loop is restarting and it's checking, is y less than 20? It's 10. It is less than 20, great. So it's going to do the whole thing again. Printing this becomes 12, prints this, becomes 15, goes up. It says 15 less than 20. Yes, it's still valid. Prints this, becomes 17, prints this, becomes 20. Checks, it says, is 20 less than 20? False. So it comes out. So the loop stops. So you have 3 iterations. Are helpful, not helpful. This happens 3 times. So C is the answer. Okay. The best way to decipher loops is to do it manually one by one. That you start off with 5, you see one by one what is happening, you go up, see if the condition is still valid, do it a few times, you will get the hang of it. Okay. Okay. All right. Now this one is slightly complicated, so I'm going to copy it into R and show you. So this was assignment 6, question 4, I think. Okay, so let's first of all write it a little. Okay, now, so as of now, we had seen that for both loops and conditional statements, you have to write it in chunks. Okay, you use these curly brackets. Okay, and you make chunks out of it, right? So here you can see that there is this chunk for the loop, but you see a chunk is missing for the if-else statement. I mean, there's no else here, but for the if statement, the chunk is missing. So when the chunk is missing, you need to assume, not assume, you need to, understand that only one line after the if statement is a part of the if chunk, not everything. Okay. And you can also see this from the default alignment that R does. So you see within the while loop, X, if, and print, they are directly falling within the while loop. And the break statement here is the only one which is shifted from if, so that's falling within if. Okay. When you're making chunks using curly brackets, you can have as many lines within that chunk. But if you're not using curly brackets to define chunks, you can have only one line for a while loop or for a conditional statement. Okay, so now this one here, so x is 22 and you check while x is less than 25, which is true. So we enter this loop and what it does is it changes the value of x. It says squaring x. So 22 square, whatever that is, 22 square, that's 484. Okay, and it says if x is 35, break. So break means you come outside the loop. So x is not 35. So you print this value. Okay, so this is 484 minus 20, right? So that's going to give you 464. That's going to print 464 and then it's going to go up. Now the value of x is 464. It says, is it less than 25? No. So that's it. The loop stops. So if I run the whole thing, you see, it just returns you 464. That's what you get here. Right? Does this make sense? This part, the if break part, was never used because the value of x was never 35. From 25, from 22, it directly reached 464 and the loop ended. Okay, Okay. Yeah, so this one's this one's like, just you need to see that it's making sense. So exponential x to the power 2 and plus x, and that whole thing you're finding a square root, and then you're subtracting x to the power this plus 40. You just have to convert it correctly, use appropriate brackets and format, and that's how you define a function, right? And for function, again, you need to have these curly brackets at the start and end of the chunk, and you say y, and then the output, when you write 2, you can just put in 2 here. And so again, for something like this, you would need a calculator. And yeah, so that's it. Yeah, so this one you need to be just careful that here, this part, you see x to the power 5 by 2. So you need to have brackets around 5 by 2, because otherwise this could mean you're saying x to the power 5 and then you half that. That's not correct, right? Because it's x to the power 5 by 2. Okay. Same is the case here. Okay. Which of the following is the correct outcome of z 14 comma 11? So basically now this is a function which is accepting two values, x and y, x being 14, y being 11, in that order, and you can just solve it. So that's there. And so yeah, so sequence. So we have seen sequence in this yeah, in this week also. So basically, if nothing is specified, so it's from and to with the appropriate increment of +1 or -1. So sequence -40 to -45, so it's going to be -40, -41, -42, -43, -44, -45. And ABS is absolute. Okay, this we had seen in one of the earlier lectures, right, when we were discussing basic transformations like this. So it's just going to remove the sign from all of them. So the order stays the same. It was -40, it just became 40. The last one was -45, it became 45. Okay, that's there. Okay, again, you're finding the sequence from to by, that jump, and you're finding the absolute of it, and then you're finding the square root of that number. Okay. Again, by, like, from to by, that you can, that's simple. Again, this is also what we have seen now. This is also simple. This one.
Ma'am, I
Yeah.
have a doubt.
Yes.
Uh, Actually, you said that key when we write absolute, when we command the ABS, the answers will turn into positive.
Yes.
Is it? Okay. So -40 will lead to, okay, +40. Okay.
It's not going to change the order. It's not becoming, it's not flipping. It was -40, became 40. It was -41, became 40, -40, like +40. So the order stays the same. Positive numbers remain positive, negative numbers become positive at that same place.
Positive numbers become
Positive,
positive,
positive remain
and
positive.
negative become positive.
Yeah.
Okay,
So,
got it.
yeah, I'll just show that to you. So I think this vector A we had, right? It has both positive and negative numbers. So if I take the absolute, so you can see the positive numbers remain positive and the negative numbers, they became positive. Yeah. Okay. So these ones are repetitive. Okay, so this one, okay, so this is, again, these are slightly, just you need to be careful. So now solve the inside bracket first. So x is a vector, y is a vector. So x 4, that means the fourth element of x. Now that coincidentally is 4. So you take y4. 1, 2, 3, 4. So that gives you 140. Right? And then x8. So 1, 2, 3, 4, 5, 6, 7, 8. That's 9. So you take 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth element of y, which is 19. So 140 and 19. Okay. Likewise, okay, there was one more question like this. But anyway, so which of the following is the correct output? X greater than 45 in X. Okay. So whichever numbers, so internally what it's doing is when you're comparing X greater than 45, you'll get true, false values, as many as is the number of elements. And then you're feeding just true, false to X. So you'll get the elements which are at the true positions. Right? So this one you'll get this, you'll get this and this one, this one, this one, and this one. Right? So option A. So again, so x minus 120 is less than 30. So wherever this is satisfied, so basically wherever x is greater than 150, you'll get those answers. Right? So this is there, that's it. Okay. Okay, which of the following is the correct outcome? Again, just a little more complicated, but it's the same thing. Okay, now if y is from 25 to 35, so these are 11 elements, what will be the output of y minus 2 to 8? Okay, now this, I don't know if you remember this. Here it's basically removing element 2 to 8. Okay, so it's going to give you the rest of the elements. Okay, so it's going to give you element 1, which was 25. It's going to give you element 9, 10, and 11. Okay. So this is not like the absolute thing. It's not, you're not putting a negative sign on the values. That would have come outside. Here, yes, you're talking about the index itself. Okay. So when you talk about the index, you're removing these indices. You're doing -2, -3, -8.
Excuse me, ma'am.
Yeah.
Can you please explain this again?
Okay, fine. So I'll just do this one here. This was question number 19. Okay, so we have x is equal to 25 to 35. Okay, so this is x here, right? Now it says, what does it say? Wait, okay. All right. So now, before I do that, if I would have written 2 to 8, this, you're selecting 2 to 8 elements, right? So element 2, 3, 4, 5, 6, 7, 8. Yeah, right? These elements, these you're selecting. But if I've written minus, so you're removing these elements, and you are left with the other elements. You have element 1, you have element 9, 10, and 11.
Okay, ma'am, got it. Yes, ma'am.
Okay, good. All right. Oh, and this is that option, right? So in 20, you have these elements, and in question number 19, you are left with the remaining elements. That's it. Yeah. Okay. So we are just well in time. So that's it then. Done with the today's class. The deadline for this week's assignment is tomorrow. So okay. So good luck with that. And I'll just stop sharing the screen. Okay. So yeah, thanks for attending today's session. I'll see you all. Sorry, I'll see you all next week. Okay. Oh, sure. Come on. Nothing about patience. These sessions are really nice. Okay, you're all asking good pertinent questions, and I'm hoping these sessions are helping you. Okay. And yeah, All right. Thank you so much. Good night, everybody.
Thank you, ma'am.
Yeah. Bye-bye.